sum of nTerms of an AP, that is the arithmetic progression, when first and last terms are given. So here we are going to discuss about the sum of nTerms of an AP when the first term of an AP and the last term of an AP are given. So here AP stands for the arithmetic progression. We are going to deal this topic under the advanced level. So here we know that the sum of nTerms of an AP when first term and the common difference is given, when there are of n terms in it. So Sn equals to n by 2 into 2a plus n minus 1 into d, whereas a plus d, a plus 2d and so on, a plus n minus 1d, 1 into d is the gen form of a arithmetic progression. We know that gen form, that is the general form of an arithmetic progression, which is denoted by AP, is given by A is the first term and the second term is of, this is of a plus 0d, a plus 1d is of d, and the third term will be of a plus 2d, 1 less, fourth term 4 minus 1 will be of a plus 3d, then fifth term 5 minus 1 is of 4, that is 4d, so it will be of a plus 4d, so dash dash, and the nth term will be of, so plus a plus n minus 1 into d is the nth term. So here first term is of a, second term is of a plus d, third term is of 3 minus 1, it is of 2d, fourth term is of 4 minus 1 is of 3d, that is a plus 3d, fifth term 5 minus 1 is of 4, that is 4d. So here fifth term will be of a plus 4d of arithmetic progression. So here nth term, that is n minus 1, that is into d, a plus n minus 1 into d is the nth term of the series, that is arithmetic progression. So here from this, so here we know that sum of nTerms. So by adding up all these terms of the arithmetic progression, so we will be getting Sn, that is sum of nTerms of the arithmetic progression, is given by means of n by 2, so into 2a plus n minus 1 into d. Whereas here a's coefficient is of 2, so I want to split 2a as 1a plus 1a. So here 1a plus 1a is gives the 2a. So here based upon this principle, by splitting 2a as 1a and as well as 1a, so 1a plus 1a gives the 2a. So I want to split it as 2a as 1a plus 1a. Then the next logical step will be of, so Sn equals to n by 2 into a plus a is 2a plus n minus 1 is written as it is. So here the reason is of 2a equals to 1a plus 1a. Then now by grouping this one together, the next logical step will be of, that implies Sn is equals to n by 2 into a plus, so here within flower brackets I want to write a plus n minus 1 into d. So a plus n minus 1 into d within brackets, flower brackets, then the square bracket is closed. So here in the arithmetic progression gen form, so here a is of the first term and the a plus n minus 1d is of the nth term. So here we can replace a by means of first term and a plus n minus 1 into d as the nth term. So this is of first term and this is of the nth term. So here, but we know that as per the gen form, that is the general form of an arithmetic progression. So here T1 first term will be of a and the nth term is given by means of a plus n minus 1 into d. Then now by replacing in the formula, so Sn is equals to n by 2 written as it is into T1 as a. So here a as T1 plus a plus n minus 1 into d is nothing but the nth term. So here, since this is the first term, so here so T1 is the first term, that is nothing but a, and Tn, so here let Tn is nothing but the last term in it. Since this is the last term in the gen form of arithmetic progression, so here Tn is equals to last term, let us suppose it by L. So here in this manner we have supposed let T1 the first term as a and let Tn the nth term as last term, that is L. By substituting, so T1 again by means of a and Tn again by means of L, so the formula will be of. So here therefore sum of n terms is given by means of n by 2, so into T1 is nothing but a plus Tn is nothing but the last term, that is L. So in this manner we got the formula as the sum of n terms is given by means of n by 2 into first term plus last term of the given series. So a stands for the first term of the series and the L stands for the last term of the sequence. So in this manner we got Sn is equals to n by 2 into a plus L. So Sn is equals to n by 2 into a plus L is the formula for finding the sum of n terms of the sequence, that is of arithmetic progression. So under this let us perform one example. Find sum to n terms of the arithmetic progression when first term is 20 and the last term is minus 120. Solution starts now. And at the same time and also find sum of 10 terms, and at the same time we have to find out sum of 10 terms. So here as per the problem, so solution starts now. So as per the problem, first term of the series, first term of an AP, that is given by means of A, that is equals to T1, first term is given by means of 20 whereas the last term, so last term is given by means of minus 120. So here last term of an AP, that is L, so which is nothing but the nth term, is given by means of minus 120. So here we have to find out sum of n terms. So a sum of n terms is given by means of formula n by 2 into a plus L, when L is the last term and a is the first term. So based upon this formula, so here let us find out the sum of n terms. So that implies sum of n terms is equals to n by 2 into a value. So a is of 20 plus L. So L is of minus 120 within the bracket. Then now that implies S of n is equals to n by 2 into 20. So here plus into minus is of minus, then 120. So here minus 120 and the square bracket is closed. So that implies n by 2 into 120 is of negative sign and 20 is of positive sign. So plus of plus, minus is of minus. We have to, in order to simplify, so here plus of minus is minus, we have to subtract greater minus least, that is 120 minus 20 is of 100. To assess the sign here, 120 is greater than 20, 120 sign is great. So 120 sign is of negative, therefore 100 assess the sign of negative. So in this manner we got the next logical step as, so minus 100 into n is of 100n divided by 2, that is 2 ones, 2 50s is of 100. So in this manner I got, so S of n is equals to, so here that implies S of n is equals to minus 50n. But at the same time we have to find out, in order to find out S of, so as per the question, so we have to find out sum of 10 terms, then sum of 10 terms. So here n must be replaced by means of 10 in order to get the value of sum of n terms. Then now, so that equals to minus 50 into n value is of 10. So that implies minus 5 ones is of 5 followed by 2 zeros, or in other words 50 tens is of 500 with negative sign. So in this manner I got sum of 10 terms is equals to minus 500. So here therefore or hence sum of n terms is given by means of minus 50n and sum of 10 terms is given by means of minus 500.